Okay, now I do want to point out that this is, I know there's two examples here on the practice test, and I'm actually okay with putting a couple examples just to make us feel better about the process. There's only going to be one of these on the test, so just relax. These are calculating mean and standard deviation from frequency data. So it's a little bit more of a specialized skill. You will get access to a formula chart on this, and so the formula we need for standard deviation is right there. The formula we need is, formula we need for the mean is right there. So I forgot to take a picture of it. Let me do that real quick. Let me try that again, just so we can, once we pull up an Excel here, we can just focus in on the two formulas that we need. Well, that didn't work out. Okay, so I will get this formula. There we go. Okay, so then from here, I need my midpoints. So let me kind of pull over Excel, and we'll come back and refer to the midpoint, the formulas here in a second. So I need midpoints for each, and then I need the frequencies. Okay, so kind of think of it like what's halfway between 1 and 2. So if it wasn't obvious, then I would be taking the two endpoints, the two numbers, adding them up and dividing by 2, and I get 1.5. Okay, so same thing with 3 and 4, so should get 3.5. 5 and 6, so should get 5.5. 7 and 8 is 7.5, and 9 and 10 is 9.5. And then frequency would be 2, 21, 20, 10, and 30. Okay, so once we've got that, we're going to abandon ship on looking at the data, and now we're going to focus on the formulas. Now, the nice part about a calculator is if you type this into your calculator, into list 1 and list 2, and then tell it when it does its one variable statistics to take that into consideration, then it's actually pretty quick to get the mean and standard deviation. If you can do it by Excel, this is the one process that takes a little more time, but it's not that terrible. Okay, so what I need to know, to find the mean, I need to sum the frequencies times the observations, times the midpoints. So I need to start by multiplying these two numbers together. Let me give that a name real quick. So if I name it, I might be able to use it later on. So this is f times x. Okay, so I'm just going to multiply these two numbers together. So that number times that number. And the nice part about Excel is since I clicked on the cells rather than type the numbers in, I can drag the values down and it will do all those other calculations for me. And then I need to sum this. So sum of f, give myself more room here. Sum of f times x, so equals sum, and then just highlight all of those numbers, and then hit enter. And then I need, again according to my formula, I need to sum up the frequencies. So sum of f I wanted to add extra stuff to my words. Alright, so the sum of f means I'm just going to add this all up. If I type the word sum in front of it, then I will add it all up. And I get that. And so the mean of the frequency table is just divide those two numbers. So take that number divided by that number. And so the mean is 6.58, blah, blah, blah. Okay, that was the easy one. Standard deviation requires a little bit more steps I got to jump through. Let's see, in my formula, I can see that I actually did something that was helpful, because I did something that was helpful. I already calculated this piece, this f times x, the sum of that, so then I just need to square it. So square of f times x. So come over here, I'll take that number times itself. Okay, so I get a big number there. So that was helpful. That sort of sped up part of my formula. Over here, I need to take f times x squared. So let me label that f times x squared. Okay, so here I want the frequency times the midpoint times the midpoint. Okay, and then I want to copy and paste that formula down. All right, and then back over here. So then I need to sum it and then take that and multiply it by n. Okay, so can I come over? So sum of f times x squared. So I'm going to add that whole new chart there that we just found. And then before I subtract, I got that n I need to take into account. And the n is the number of frequencies. So that's actually this 83 that we found earlier. So n times sum of f times x squared. Okay, so that's going to be this number times n, which is the 83. Okay, so then I got that. And according to our formula, then I want to subtract those two. So minus that. Almost done. So I get this number, 44,688. All right, and then I want n times n minus 1. So I come over here, n times n minus 1. Okay. So that's going to equal 83 times 82. All right, and then I want to divide and then take the square root. Okay, so let's take that number divided by the product we just found, and then I want to take the square root of that. Okay, and so I get a standard deviation of 2.56. Okay, so all of this, can I come back over here? That was my mean. So I'll highlight these two numbers and make sure I'm supposed to notice this. So that was the one answer and that was the other answer. Okay, so with the second chart, it's the exact same setup as the previous chart. And actually we can use a lot of the work that we did. So what I'm going to do is I'm just going to quickly do it off to the side, and then I will post the answer up so you can kind of compare, but I don't really think you need to watch me do it necessarily again for the entire formula, but I will post the answer up so you can see what you should get. Okay, so I thought I would just take a second and post the final answer. So the mean for that second set of data is 58.6 and the standard deviation is 3.1. And so you can kind of see setup wise what my numbers are So you can kind of go back and compare if there is a discrepancy. You know, I didn't have that number. My number's different. At least you can go back and compare and see what it should be. All right, number 19. This is a great application of a frequency data. You know, what's referred to as how does one even calculate a weighted GPA? So let's kind of go through the example here. What we're going to do is we're told the grades that someone earned and how many credit hours they're worth. And we're going to go back and use this frequency, the mean of frequency data. And so we're going to translate each of these grades into its weight. So we'll do weight, and then we'll do credit hours, and then we'll kind of go from there. So a C is worth 2 points, an F is worth nothing, a D is worth 1, an F is nothing, and an F is nothing. Okay. And then credit hours would be sort of like frequency. So 3 those, 1, 2, 2, and 3. Okay, so what I want to know is I want to multiply frequency times x. So I want to multiply these two sets of numbers together. So this number times this number. And I'm just going to copy that down real quick. Now, according to our formula, I actually want to know what the sum of that is. So I'm going to sum up all of those numbers. And then I want to sum up the total number of credit hours. So I'm going to highlight those. Okay. And then, last but not least, I want to divide. So in other words, this particular student earned 8 points out of a possible, not necessarily 10, but you got to think if they earned A's and everything, it'd be, you know, so they could have gotten 40 points to get a 4.0, but they only got 8 points. So their GPA is 8 divided by 10, or 0.8. So clearly, they're not even a D student. They're a 0.8, so almost a D, I guess. All right, 21. Many firms use on-the-job training to teach their employees new software. Suppose you work in the personnel department of a firm that just finished training a group of its employees in the new software, and you've been requested to review the performance of one of the trainees on the final test that was given to all trainees. The mean and standard deviation are 73 and 2, respectively, and the distribution is mound-shaped and symmetric. Suppose the trainee in question received a 72. Compute the trainee's z-score. Okay. So, just good old-fashioned z-score here. So our z-score is observed minus expected divided by standard deviation. Now, it's clearly going to be something negative. And I'm just going to go use Excel as a calculator. 72 minus 73 is negative 1. And divide that. So it equals that number divided by 2. So I get a z-score of negative 0.5. Okay, so clearly this person is below the mean. All right, last but not least, a certain population has a mean of 12 and a standard deviation of 2. Draw the density curve and mark the mean and 3 standard deviations from the mean. Label percentages from the empirical rule. Okay, so it's kind of saying think of the normal curve and let's fill in what 1 standard deviation, 2 standard deviations, and 3 standard deviations are. So if I take 12 and add 2, I get 14, and subtract, I get 10. Okay, and this represents, in the empirical rule, 68. Sorry, misspoke there. Okay, so that's 68% of the data is there. If I go one more standard deviation out, so I'm adding and subtracting 2, Okay, that puts me at 95% of the data. And if I go one more standard deviation out, that's 99.7% of the data should fall between this. So that's all I'm looking for on this, is an illustration of if you go certain standard deviations out, what one should see.